Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in the C++ series. In this lesson, I'm going to kickstart a series of lessons about classes in C++. And classes are one of the defining object-oriented programming structures that are used. And it's, again, this idea that you can create a new data type to represent some object in the world and have within this data type the ability to have actions associated with this particular object, as well as the data that is being operated on and performing these actions all in one nice place. So with that said, let's go ahead and take a little bit of a closer look at classes in C++. So where I want to go ahead and start us off is, again, just from one of my favorite C++ websites, Cpp reference, and in the search box, just searching for a class here. And let's go ahead and just get a little bit oriented here with what a class is. And you'll see that there's a bunch of different help pages here. I'm just going to go to classes down here, and this will provide a high-level overview of what a class is. And the very bare minimum I want you to take away from this lesson is that it's just a user-defined type. So what does that mean here? Well, let's go ahead and summarize a little bit of this information here. So a class is a user-defined type. And if you've been following this series, you'll sometimes see me abbreviate this user-defined type, but don't worry, I usually write things out because I don't like abbreviations. But all this basically means is a primitive type is something like char, int, float, etc. These are primitive types, or sometimes you'll see them as built-in types in the language. So of course we may want to represent things that are not just integers, chars, floats, doubles, booleans, etc., etc. These built-in very simple types. We want to create our own user-defined types. So classic example is maybe I would want to have a type that represents a student, and we could name that student Mike, for instance. So here's the user-defined type. This is a new class or a new data type. And here is a instance. So this is the actual data type here. And this is the instance of a student. And this is going to be the essence of object-oriented programming. This idea that we can create different objects like Mike in this world, and they are these particular user-defined data types. So I think now it might be easiest if we just go ahead and look at an example. And I'm going to go ahead and leave this page up here, and let's go ahead and write a little bit of code here. So I'll go ahead and just create a new directory here for this lesson, and let's just call this classes part 1 and move into this directory, and let's create a main file. I'll split my window so we can see multiple views. And let's create a main here. And for this lesson, let's go ahead and just include IOStream. And let's go ahead and create a class. So how do we create a class? Well, following from the documentation, we have the class keyword here. So class. And we should give it a name. So student. So this is the new type that I am creating here, student. Okay, let me make this just a little bit bigger for you. And in C++, we also have structs, which we can use, and they vary slightly in how the information is viewed within this data type here. So again, this is a class. You'll see the curly braces, which is the sort of scope of this particular class here. And we can make information inside of this class public or private, for instance. Okay, and by default, everything in a class is private. So I'm just going to leave this up here so that we can see this here. And again, this is one of the major ideas in object-oriented programming, or one of the advantages here. So let me go ahead and just note this down here, and I'll keep a few of our notes here. We can perform information hiding. And well, what do I mean by that? Well, let me write it a little bit nicer here. Information hiding, public, private, and protected. Okay, those will be the three sort of classes. We'll get into those a little bit later. Today is just an intro to some of the things that we can do in classes and building our first class here. So the information inside of this student class, for instance, could be hidden and not available to someone, or I could make it public. Let's go ahead and make it public just so that it is available and we can do some simple example with today's lesson. Okay, now looking back at our documentation here, you'll see that one of the next important things here, and I'm going to go ahead and scroll down, is that a class can have members associated with it. And these are things that are grouped together within this class here, the student. So these would be the data members or the member variables and the member functions or the actions that can take place. So let's go ahead and create some, for instance. And I'm going to create some special ones here, which I'll talk about in a moment here. Student here and here. So these are the actions. Okay, the actions. And I'll call this a constructor, and this is a special one, and the destructor. Okay, and let me just make a note here that these are special actions. And let's go ahead and just denote this one also as a special action. And I mean this term special in that this constructor, if you're coming from Java or Python, you're familiar with this idea, is this is the function or member function that is called every time we create a new student. And this is the destructor that's called every time a student is destroyed or leaves scope. So either explicitly called delete on or is destroyed. Okay, and let's go ahead and create maybe some private data members here. So these are hidden fields or attributes of our class. Okay, so this would be the actual data that we might want to associate with a student here. And I'm going to go ahead and include a library here, string, so that we can, for instance, store a student's name here. So from the standard library, we'll have a string and the name. And I like to prefix my member variables here, or my data members, with an M and an underscore in front. That's just a convention that I use so that I can just keep track of what kind of variable this is. All right, now just to make things a little bit interesting here, I'm also going to print out the constructor function because I want to talk about that a little bit, and the destructor function as well. Okay, so we'll just have some printouts here so we can see when these actions take place. Okay, and let me go ahead and move things together here just a little bit so we can see everything on the screen. And let's go ahead and just flip it this way. Okay, so let's go ahead and create one of our new user-defined types. That is here. So student, our new user-defined type. And let's create an instance of a student, okay, or i.e. an object. Okay, so student and Mike, for instance, would be one instance of some student, and well, I'm giving them the name for myself here so we can keep track of it. All right, let's go ahead and compile this and go ahead and run this. So I'll use G++, and this is our main -o prog, and I'm not using any special C++ features here, but I do like to consistently use C++ 17 or later in this series. Okay, so no compilation errors, and I can run this, and you'll see the constructor and the destructor called. Okay, so again, let's slow everything down for just a moment and review what we've done. So we've got our main, which is our entry point in every program as usual. And then what we've done here is created an instance of a student here. That's Mike here. So an instance of student, or this object, Mike. And this is the custom type that we have, the student class. So we use the new keyword class, student. We make some functions available, these member functions. And these are special ones, which I've got to talk about, student and the little tilde mark and student here, which are the constructor, which is called as soon as I create this instance, and the destructor, which is called as soon as Mike is destroyed. So in this case, I would go out of scope at this curly brace. And just to make this a little bit more clear, I'm going to go ahead and just create a new block scope here. And just go ahead and do some couts here. So program starts. And let's go ahead and do one more here. Program ends. Okay, just so you can explicitly see where the constructor and destructor are automatically called. So program starts, that's printed out, and then we have Mike here. And then as soon as it leaves scope, so as soon as it's between these curly braces here, the destructor is automatically destroys this object here. And we can see program ends. Okay, and let me do this just a little bit more explicitly. If you want to create an object that's not on the stack here, but instead say allocate one Mike here. So new student. Okay, so this is just creating one instance of our new student here. So let's go ahead and compile this. I run this and, well, we can see the constructor is called. Recall that's what's happening here at line 26. I'm saying, hey, give me a new student, but it's actually never destroyed because I didn't explicitly call the destructor. Well, I can't actually call this function. That's what makes it one of the special functions in C++, which we will continually talk about. I have to explicitly delete it. So I have to delete Mike here, and then we should see the actual destructor show up here. Okay, so now we can actually see the destructor is called. Now, what purpose this destructor is, we'll do some examples and build some data structures later on so that we can see how this actually works. But that, again, is just describing what this constructor and destructor actually do. Now, something you might be wondering here is, well, we haven't done anything with name here. You know, it might be appropriate to, for instance, name our actual student. So what if I, let me go ahead and just simplify this just a little bit. I'm going to go ahead and get rid of this since we sort of understand the scope of where destructors and constructors are called. And let's go ahead and do Mike m name equals, well, Mike here. Something like that. Mike and my last initial. Now, if I compile this, well, what happened here? I actually got an error here. It says m name here is private within this context. So this is showing the idea of classes and one of the powerful ideas with classes in C++. We can hide the information that we don't want someone who's creating students to actually access, because maybe this is really important that we don't change this value. In fact, we just make it private here. Now I can fix this by just making it public, for instance, and then you'll observe that I can in fact run and compile this program, and if we printed out Mike.mname, this would change. Okay, so that's the idea of public versus private when creating classes in C++. And the larger idea, if you want to explore this, is this idea of information hiding. Now, folks will stylistically do things like write getter or setter functions sometimes, and depending on your API, that is your how you're designing this class, that may or may not be appropriate. So why don't we go ahead and just write a function for now called print name, and it will just print out the name. It'll say name is, and we'll just print out m name here. Okay, and well, let's go ahead and just make this public so that we can access it. And then we'll keep talking a little bit more about this idea here. But I just want to show you this new action or member function here, print name, that we have just created here. So I'm going to go ahead and do Mike.printName. And let's go ahead and see what happens when I compile and run. I construct my object, so it's being built. So this would be any initialization that needs to take place when I create this object. And that could be done in here. Then I set the name here because, well, this is a public variable, so I can access it outside of the class and set the variable. And then I call print name, which for each instance of our objects here. So Mike is one instance of an object. We look at what's Mike's name. Well, it's been set to Mike S. So effectively, that's the value that's stored here in mname for this particular instance, and then it's printed out. And this is, again, showing a powerful idea of object-oriented programming. So let me go ahead and continue here. And this time, I'm going to create another student here. And I'll just call this student Sue. And let's go ahead and just update and set Sue's name appropriately. And now we will run this program. So it compiles and runs, and you will see the constructor is called for, well, our Mike object. That's the first one that's being constructed. And we print out the name for this object. And then we have another constructor that's called when we are constructing Sue here. And then we print the name for Sue. And then each of the destructors are called appropriately. So destroying this object Mike and then destroying Sue. We see the two destructor calls here. Okay. And it might actually be a little bit useful now to actually just call the destructor and maybe print out the name here. So let me go ahead and recompile this, rerun it, just so you can see that Sue is destroyed first and then Mike. Okay. So it's just sort of a stack order, meaning if Mike was the first to be constructed, it'll be the last to be destroyed here. Okay. Now, just to review the importance of this, so let's go ahead and bring up our little diagram here. Along with information hiding, the advantage of having classes or enabling this object-oriented programming is the ability to create instances of objects and think in objects in our software. And okay, so what exactly does that mean? This ability to create instances of objects and think in objects in our software. Well, that's what I've essentially done here in this code here. I've modeled a object or created an object here. I've grouped the data together, and then I have actions that can be done. And this is often how we think about things in the real world, for example. If you have a car, you might want to know some of its attributes, that it has 4 wheels, that it has a V6 engine, that it can store 8 gallons of gasoline, and these various attributes. And then there might be actions associated with it, like the ability to drive, to turn left, turn right, turn on the turn signal, etc. And then you might want another instance of a car, but be able to tweak some of those attributes. So maybe it only has, maybe this car has 6 wheels for whatever reason, and 2 doors, and so on, that you can change these actual attributes. So in a way, object-oriented programming can simplify how us as the programmers model our programs and collect the data and the actions together. So this is the basic idea of doing object-oriented programming. Now, I do want to push this lesson just one step further from a previous lesson where I talked about interfaces and just show you how to properly organize a class here, because we've created this student class here. And as you can imagine, you might have many classes or user-defined types that you want to create in your project. So what I'm going to go ahead and do is, let me make this a little bit smaller here and just get organized here. And basically, I'm going to move this class into another header file. So let's go ahead and just create student HPP. We want to create some header guards. So if not defined, so if and def here, student HPP. Again, usually I use the file name. And I'm just going to now copy this class here into this header file. Okay. And then I could, for instance, include using just quotations because this file exists, if I go ahead and show you, in the same directory as main here. So this is the relative file path. So let me go ahead and save that here. And now I could compile this. Let me go ahead and make sure I save and run it just as before. Okay, so there it is, same program. Now, if you're paying close attention, though, you're going to say, well, Mike, in previous lessons, when we've talked about the interface, which is the thing that goes in your header files, why is there actual implementation code? And you're exactly right. So we do have to go a step further here and actually create student.cpp, which includes our student header file, the interface. And this is where the actual source code implementation will go. So I'm going to go ahead and just clean this up a little bit here. Let me get rid of some of the comments just to make this a little bit easier to read. And I basically want the implementation of these functions to go in here. Okay, so let's go ahead and put them in here. So what does our header file look like? Well, now our header file is just a high-level view of our code here. So I can literally get rid of all of the implementation details. And someone who's looking at our header file will just say, oh, I can create a student. There's a constructor. I can destroy a student. I can print its name and so on. Okay, so let me say this action, print the student name here. Okay, so it's nice and clean here. So now I actually have to go into my implementation file here and build the student here, the constructor, destructor, and so on. Now let me go ahead and save everything here and go ahead and show you what happens. So I have main here, and well, if I just compile main, what's going to happen? Well, let me go ahead and hit enter, and well, we're going to get a bunch of undefined references here. And again, that probably means, or what it exactly means is, hey, you've included this student HPP header in your main file. And again, let me just prove that to you. What do these messages mean here? So main, right? I've included this here, and I'm using student, as you can see down here. But, you know, we don't know what a student is, how to construct it, and so on. Okay, so that means, again, we need the implementation, which belongs in student CPP. So I've got to compile that file as well. And, well, uh-oh. Now I'm getting a bunch of really weird errors here. It says mname's not defined. Well, I thought mname was part of the class here, but we actually have to go one step further here. And these functions, as they stand here, are just essentially free functions. The C++ compiler doesn't know that print name is associated with this print name here, which is in student. So it's within the class scope of student. Okay, so let's go ahead and look up that term here. And let's rely on CPP reference here, class scope. And, well, there's a bunch of scope here. So let's see, block scope we've learned about. Let's see if there's one for class scope. Well, here it is. And basically, if I create some struct, which by default is the same as class, just makes everything public, then I need to be able to tell which functions belong into it. And that's where the : or the scope operator comes in. Okay, so it's probably easier if I just show you that I need to say, hey, this constructor, what class is it part of? It's part of the student class here. Okay, and here's student again. And print name, it's part of student. So I put in student, the class name, and then : which tells me scope. That's the scope operator. And then I can compile this. Oops, let me make sure I save everything. And I'm going to give this one more run because I did see some errors here. And well, now my errors aren't so much related to mname, but IOStream here. And that means I need to include the IOStream library. So where should I include it? Well, if I include it here in this header file, essentially when I do the #include, that's going to copy and paste the contents of this entire file here on the left into this file here. But usually I just want to show the or include the libraries that I actually need in this file, right? I'm not doing any IO stuff on the left side of the screen here. I'm doing it on the right side. So let me go ahead and include IO stream there, and I'll go ahead and compile this. And let's see. Well, still one more mistake here, and it's complaining about mname. Well, where do I use string? Well, I am using that in the header file here. Okay, so let's go ahead and include string. And I'll go ahead and compile. And now our program works as before. Okay, and let me go ahead and split and show our main project here, just so we can see everything. Now, I don't need to include string or IO stream here, just the student, because those are taken care of there. And I can run this here. All right. So I'm going to go ahead and leave this here and just provide a quick summary of what we learned. And, really this is our introduction to classes. So we learned how to use the class keyword, create a new user-defined type. This idea that we have something called a constructor that's automatically called when we create an object, and a destructor that's called automatically when an object is destroyed, whether that's an object that leaves scope or is explicitly deleted. And we can have any number of associated actions or member functions that operate on data inside of the class. And these are our data members or our member variables, and I like to prefix them with an M underscore. Now, usually we separate out our classes by providing the interface in a header file here. That's the HPP. And then we provide the implementation in a C++ file. So that's over here on the far right screen. And for each of our member functions that we're implementing, we also tell the scope. So the compiler knows where to find this function here with the scope operator and the name of the class here. All right. And then we can include whatever dependencies we need in these files so that C++ knows that we have a string here, or if we're using IO stream in our class, that it exists here. And then when we're ready to use our user-defined type, we simply include the header. We can include it as many times as we need it in our project across multiple different files if we need, as long as we have our header guards here. All right, and then it's as simple as just creating an object, Mike here, which is an instance of student. All right, so go ahead and give yourself a few moments to maybe implement or try out this actual lesson. There's a lot of code there, and I might have moved a little bit fast, but we're going to be revisiting some of these ideas. And I really wanted to show you how to do it right in this lesson. That is how to split things up into different files. So again, if you need to, feel free to check out this code as much as you need and slow down the lesson and follow along as needed. It will really help you as you type out. And it's okay to make mistakes. That's part of learning about this. But what's really exciting is that this is your introduction, perhaps, if it's your first time seeing object-oriented programming, and it's a really powerful way to organize your code, and it can often make projects, especially if you're working on very large projects, easier to work with. And it's abstraction, or I should just say that the abstraction provided here is what can allow you to more easily build larger software. Now, whether that's a good thing or a bad thing, or what the trade-offs are with object-oriented programming, we'll hopefully get in this series or another one in the future. But with that said, I hope you're excited as we kickstart a few lessons on classes here and continue your C++ programming journey. So make sure that you like and subscribe so you don't miss those future lessons, and we'll see you in the next one, folks.